Next, the first example along structural components of a bridge has an ellipse cross section shown in this below figure. So this is ellipse cross section. Okay, it is known that when a steady wind blows passing this type of the buff body, vortex may develop on the downstream side. So this is what vortex develop on downstream side. So that are chased in a regular fashion on some finite the frequency. Okay, since this vortex can create a harmful periodic force, okay, acting on the structure, it is important to determine the shading frequency. Okay, for the specific structure of interest, diameter is 0.1 meter, and the height, this width and the length h 0.3, and a representative wind velocity is 50 km per hour. Standard air can be assumed, and the shading frequency is to be determined through the use of small-scale model that is to be tested in the water channel. Okay, for the models, Tm is 20 millimeter and the water temperature is 20 degrees C, and determine the model dimension Hm and velocity at which the test should be performed. If the shading frequency for the model is formed to be 49.9 Hz, what is the corresponding frequency for the prototype? Okay, that is what we have from the prototype. Prototype is air, but we going to use the model is the water. Okay, that is the given dimension for the h, and the question is what is the frequency, the shading frequency for omega. And for model we have dm, and frequency for model is 49. So we have what parameter we have 1, 2, 3, 4, 5, 6. So we have 6 variables. Okay, depending on the, and the question is, so we start from write the basic dimension of the 6 parameter 6 variable based on MLT. So I mean R is 3. Okay, for the frequency shading frequency, the basic unit is the length 1 over t. The diameter is length, and h is length, v is l t minus 1, and length c is m l minus 3, and for viscosity, then viscosity m l minus 1 and t minus 1. Okay, so we have k is equal to 6, so pi term is 3. Okay, so if we work from the previous based on Buckingham pi theorem, so we can estimate 3 pi term that equal to omega d okay, so this term is a Reynolds number. And for this term we call the Shorehorn number. Okay, this is the name of the dimensionless parameter. Okay, and we find similarity between prototype PRO, prototype So this means the first set we found that we used dm over hm equal to d of the prototype and h of prototype, and low model low vd. Okay, and then next we can find what is the h from the first similarity. We found that hm equal to dm over the d and h. So we can estimate what is the height of the model. Substitute diameter of the d of the model. So the height of the model is equal to 60 10 power equal to 60 millimeter. Okay. Next we use the second dimensional parameter, which is its Reynolds number. So we can find what is the v velocity of model, ratio of the viscosity, ratio of the density, and ratio of the length and v. Okay. And then next we have to find what is the viscosity and the dimension density of the model and prototype. So the next for the model, for the prototype we use the is air. So this is mu of the air and the mu of the rho of the air. And for the model we use water. So this is the viscosity of the water and density of the water based on 20 degrees Celsius. Next we can find what is the velocity of the prototype. Given the from 50 kilometer we convert to meter per second. Equal to 13.9 meter per second, and we can estimate the for the model is equal to the ratio of the mu. So we put mu m divided by mu of the air. And the ratio of the density of air divided by water. And the ratio of the length d. Time velocity of the prototype. So we got the velocity for model is about 4.79 meters per second. Okay. If we test in the water tunnel, so we apply this dimension variable threshold. Okay, so we can estimate what is the shading frequency for prototype. Ratio of V and VBM and D. Substitute the velocity of the prototype 13.9 and divided velocity of the model and the dm of the prototype divided by d of the model divided by prototype, and for the model 49. Okay. So we can estimate that for the shading frequency for prototype is equal to 29 Hz to test in the water channel.